In this video, we will introduce the use of OpenVas as a vulnerability identification scanner and providing some overview of its use and setup. Before we get into the actual nuts and bolts of the demonstration, I will provide a brief overview of the different components that will be covered. So what you have in front of you is kind of the outline for the actual demonstration. The first thing we'll need to do is make sure that we enable our virtual machine, specifically Kali, to be able to go out to the internet and download the necessary installation package for OpenVas. The next thing we need to do is make sure that we, in order to facilitate the process of connecting to the internet, we need to request a new address and move out of the host-only network. The next thing we will proceed with is we will optionally download the updates for the operating system as well as any installed packages for Kali. And again, this is an optional. This is not a requirement because it adds some time to the overall completion of the lab. It's estimated it takes about 20 to 25 minutes additional time. And then the following component will be actually the download and install of OpenVas, and that will be the apt-get using the apt-get method for retrieving the installation package. So this actually will take about 5 to 10 minutes, and following the download, we're actually gonna go in and set up OpenVas. During this process, the initial setup script will set up the different components that allow for OpenVas to perform its vulnerability identification magic. We'll set up the different accounts that are needed, and we will actually go in and download some of the network vulnerability tests that will be used to discover actual weaknesses. The whole process can vary, so it will take about 30 to 35 minutes to download the NVT content, that's the network vulnerability tests. If your download speed is at least 31 megabits per second, so if you have a slower internet connection, to download the 880 megabytes of content may take longer. And then what we will do is after we've downloaded the necessary content, we need to start OpenVas, and to start it we can actually use the GUI or command line, and then we will need to access OpenVas. So with the access, we'll need to actually use a browser. We'll use the Greenbone Security Assistant, which is the interface to actually interact with the OpenVas framework. Provided our default credentials, the default username for OpenVas is admin, and the password is randomly generated upon successful completion of the initial setup of OpenVas, which is the previous step. Then what we need to do is, once we successfully sign into OpenVas, we're going to go ahead and create a new task. The task is an actual scan, and we need to define the parameters for that scan. The initial component is we need to provide a name. After we provide a name, we need to provide a specification for the type of scan. And the full and fast scan is going to be the one that will be probably the shortest time, most comprehensive, and will address the objectives that we have, particularly for the vulnerability identification lab. During the creation of this new scan task, we'll also add a target. So we got to tell the scan, which target we are interested in evaluating. As part of the process of adding the new target, we'll demonstrate how to make sure we're scanning every single TCP port for the target. And the reason for scanning all TCP ports, while this can be a very exhaustive process and potentially overload firewall resources, if you're in between different networks and there is a firewall in the middle, it's the most holistic approach. If we only look for port 80 and 443, we may not see that we have vulnerabilities on port 21, 25, and other ones. So from our perspective, if the scope is find any vulnerabilities anywhere, we scan everything, and there needs to be an understanding of the caveats. There's a potential for denial of service, and that's why when we schedule these scans, sometimes we need to schedule off hours, and for this purpose, as professionals, sometimes the service charges can increase for performing those scans off hours. Fortunately, a lot of these scans can be scheduled. Again, the only negative is that we need to have the readiness to pause or stop them if particular conditions of undesired effects are actually taking place. So with this in mind, what we need to do is get into the actual setup for OpenVas. So I'm gonna again make sure we work with the Kali VM, the default username root and password Tor. Hopefully, we are following along and we're on the same page. So the first thing we need to do is make sure we go to machine, we go to settings, and then we go to network, and we change our adapter from host only adapter to NAT. Okay, we click OK. So at this point we should be able to, and I kind of predid those because it took awfully long time. So what we need to do at this point is I'm gonna kind of run through the whole process. Open up terminal, and that's in the upper left hand corner, or on the all the way on the left side. And since I have a number of them open, I will go in and do this. So now let's see, do the ifconfig. I obviously have the IP address for the host only network. What I need to do is I need to request a new address from my DHCP. Now this is the IP address for my private home lab network, and I know this is correct. Now I should have the ability to go out to the internet and download OpenVas. So apt-get install yes to install OpenVas. And because I already have it installed, I'm not gonna actually have a success in this. But this typical process will take between 20 and 25 minutes, if I recall correctly. So once this is completed, what we need to do is we're done actually with the download. We need to go in and actually start setting up OpenVas. So since I already have it set up, I'm going to show you the command that I had to, and what happens here is here's the window that I had my OpenVas initial install. So it went through, it started building dependencies, started downloading the necessary package and dependencies for OpenVas. Obviously, it went through different iterations of download, setup, preparation, and then when everything is completed, I see the actual cursor here. So once this is out of the way, what we need to do is we need to set up OpenVas for initial configuration. The way we can do this is come into the upper left, click on applications. So upper left, applications, vulnerability analysis. And now in the vulnerability analysis menu, where we'll notice that we have three options for OpenVas. The first one is the initial setup. second one is the start, and the third one is the stop. Okay, so once we set up OpenVas, then we can come back here and click on the start or the stop if we have any issues with OpenVas. So you left click on the initial setup, and from that point on, what's going to happen is the initial setup script will be invoked. With the initial setup, you will see a window like this one here. So the initial setup is going to go in, create necessary certificates, user accounts, and start downloading content. So what you see here, this is content throughout the years. It looks like OpenVas came to life in about 2008, and it's gradually downloading all the content for the different years to be able to help us with the discovery of different weaknesses. So this process will take probably the longest time, somewhere between 40 and 45 minutes altogether. And this is again based on the bandwidth that you have, the actual speed of your connection. So once all this is downloaded, it was about close to 880 megabytes, maybe close to a gigabyte. Then you can see a tracker here from, I think it was like 89 to obviously like a zero number of actual NVTs, and it looks like there was another iteration of 38. So upon successful completion of the entire initial configuration of OpenVas, you'll be presented with this user created password. That's initial password. If you lose this, I'll provide some commands on how you can reinitiate it, but it becomes a complicated process. So this is a very, very important step. Make sure that you screenshot, make sure that you copy and you save this password, okay? So once I had this saved, the next thing to do is start the OpenVas service. There's two ways to start it. As I mentioned, go into Applications, Vulnerability Analysis. From Vulnerability Analysis, we go into OpenVas and we click on Start. Or we can use the terminal and invoke OpenVas, and in here I use the autocomplete. So I type in open and VAS, and if I hit the tab, I'm given with potential options. OpenVas, and I'm going to do start, and obviously start and start with both, but if I do STA and I hit the tab, so STA, and then I'm going to press the tab key, see how start was auto-completed, and then I hit enter, and this will tell me that the OpenVas service was started. Once the OpenVas service is started, what we need to do is access it. Applications, favorites, start up Firefox. Okay, with Firefox, the address we can use is https://127.0.0.1, that's the loopback address, or localhost :9392. So the essentially the address is the same. The middle part here, we're using the host name, localhost. Well, not the host name. We're using the loopback address, localhost, and we can use the instead of the name, we can use 127.0.0.1, which is the designated loopback address. Once we do this, we're going to see that the self-signed certificate throws a browser error. We need to click Advanced, add exception, confirm the exception, and then we'll be presented with a login screen. At this login screen, the username is admin, and then the password, again, it's in the terminal window. It's so important to capture that. It's not going to be end of the world. We can reset it, but obviously you're going to go through some processes to be able to reset it. We have to add a new user, got to make sure that the user has the necessary certificate, so when we launch a scan, we actually can see results. And it's an intricate process, but nevertheless, after 5-10 minutes, if you follow the directions correctly, you'll be able to get in. So in here, once you're signed in, you're gonna see a dashboard. The way that OpenVas is set up, you have a dashboard with a high-level overview of the different network vulnerability tests that have been imported, and there's over like 100,000 of them, or close to 100,000. It looks like 97,408. Then you have the different scans. Then you have the assets, and this is the different targets that we have, and they're classified by host, operating system. You have a configuration with security information, and that's the CVEs, account vulnerability exposure, the network vulnerability tests, their OVAL definitions, some certain information. The actual configuration is you can manually import a number of targets. For the purpose of the demonstration, the target will be added as part of the new scan process. Port lists, if you want to create some customization credentials, if we were to do authenticated scan. The benefit of doing authenticated scan is we can see an inside out perspective of the system health. What we will be doing is outside in without credentials. So for Metasploitable, if we're doing inside out, so authenticated scan, we'll be able to see a lot more missing patches and stuff like that. We can set up some alerts, reporting formats, agent scanners if we have multiple ones, and so on. And then the extras are the trash can. There's a CVSS calculator, which can be kind of neat. The only caveat is an outdated version. It's a V2 versus V3. So the way that all the vulnerabilities will be organized is from 1 to 3.9 is going to be low, from 4 to 6.9 is going to be medium, from 7 to 10 is going to be high. With CVSS v3, the same classification up to high. So once we go from 7 to 9, everything is high. From 9 to 10, it's critical. So in here you can do a calculator if it's a new vulnerability, and of course it's a base. I highly recommend to use the National Vulnerability Database CVSS v3 calculator, which is more comprehensive. It gives you the environmental and temporal score. So in combination with the base, you can calculate an overall score, which is adapted to the context of your organization, safeguards, likelihood of public exploit, report confidence, attack surface impact, and other components. So let's go ahead and create a scan, and what I've done is already obviously completed one iteration of the Metasploitable scan, but for the purpose of demonstration I will create a scan of the local host, and then I'll show you, what some of the results are for Metasploitable. Obviously I don't need to reveal all the goodies for your assignment that will spoil all the fun. So the first thing we need to do is under scan, we're going to go to tasks, and from the tasks we're going to see a kind of a dashboard, higher level overview. This for you will look a little bit different. You're not going to have any results pre-populated. So we're going to go ahead and create a new task, and I'm going to hover over the little star. I'm going to go to task. For the task, you're going to type in your name. Then we need to select a target, and obviously I already have a target. In here you need to specify the Metasploitable target. Since I already have it, I'm going to do the Cali, and I need to specify the address, and it's going to be the default one, 127.0.0.1. In your case, the task will be a manual IP address. You need to enter that as whatever the IP address is for your Metasploitable VM. In my case, my Metasploitable VM is going to be 192.168.56.101, if I remember correctly. So once you define the target, then the next thing you need to do is come to the port list, and we're going to specify all TCP ports, okay? And the reason being is there's 65,535 ports. If we do a regular scan, it's going to include probably the most common 1024 ports. With this, we decrease our visibility. Sometimes, as a recommendation, actually, we shouldn't be using default ports. And if we're not looking for every single port, it's going to be difficult to provide a holistic overview of the health of the asset. We'll be missing things and create a blind spot for the client. So once this is created, we click create to actually do the target. So now see how the name populated here. What we need to do is specify the type of scan. So in the scan config, we want to make sure we have the full and fast. So the full and fast is kind of the initial stage. This coverage is going to tell you if the asset is there. It's going to try to do some kind of an nmap, high level information. Host discovery, it's essentially ping is it there, and system discovery, it's doing a high level, maybe like a OS guess. So that's kind of the difference. If you go into the ultimate, it's ignoring the previous results. It's kind of starting from scratch and starting to introduce some more intrusive scans that can actually break functionality and truly cause denial of service condition. So once you create that, what we need to do is come in and initiate the scan. So you click start and the scan will start. So now that we've created the actual scan, let's go ahead and initiate it. We click on the start menu, and then we see that the status has changed to requested. In the dashboard, we can see that we have one scan that's been done, one that's been requested. Now, if you look into the top right hand side, we have a refresh. By default, your refresh is going to be set to no auto refresh. And in order to actually refresh and see the updated results and the status change, you have to come in and manually update, refresh the page. Now, if you change this to every 30 seconds, you'll automatically see the status change. So it looks like I clicked away something. But going back to the scans, you see that it's at 1%. So in 30 seconds, the screen is going to flicker, indicate that there is any change, and so on. I have to warn you that the actual Metasploitable scan took probably 35 to 40 minutes. For some of you, it may take longer. It varies based on the hardware specifications for your VMs, excuse me, as well as the components that you have selected for the scan itself. My recommendation is to use the defined settings so that the results are what I would have expected for the assignment. Now this is the waiting game. What's going to happen is the scan will go through 100% complete. We can actually go ahead and click on the completed scan, and from here we can see that there was a particular task that was finished. We can see how long actually it took. In this particular case, it took 22 minutes. If we come back to scans, we can go to reports, and the reports is going to be the actual human readable data. We can see that we have one report for a completed task. We can see a high level that there were 25, highest mediums 36. There were some low findings. From here, we can click on the actual completed scan, and we can see a list with different vulnerabilities. Of course, it's not going to be the entire list. I'm not going to spoil any of the fun that you will have with the actual results. I clicked on one of the findings, and what we can see is regarding the R services. R services are essentially remote login services. We can see that the actual category of mitigation, it's disable the service. So if you notice the little icon into the solution, as well as the summary here, is the same. Then we see the severity. 10 is because it's CVSS score 10. And the qualitative risk qualification is high. The quality of the finding and the accuracy is 80%. You can see the IP address that it was found against, and then we can see the actual port. And here we can make some overrides or add a note if we think it's a false positive. Information about the vulnerabilities presented here. It tells us the actual result, what is the solution, and it gives us some additional references where we can find additional information. Now, with the reports, what we can do is we can report this or export this particular finding. We can also see the corresponding task, and this is the actual scan that this came from. So that's kind of in a nutshell some of the information. Now if you go back into the results, it's important to note how to export results. So from the reports menu, what we can see is going into the particular completed report. Now you're not going to be able to get all the results and get the actual file, report file, if you didn't complete the scan. The actual reports that we'll potentially will be using is you can use the CSV hosts, the actual results. HTML is a human readable format, and it would look something like this. It gives you a high-level summary. This is pretty neat to be added to the appendix section of an actual pen test report, or you can use parts of the report for your executive summary. And then it goes in and highlights some of the high-level things that he found out. It provides the same information I just went over from the Greenbone Security Assistant graphical user interface. So that's the report in HTML format. The other format we'll be using is the NBE, and this particular type will allow us to potentially integrate with a Metasploit. And the purpose of bridging OpenVas and Metasploit, with OpenVas we discovered a number of vulnerabilities, related ports and services. On Nmap we discovered just the open ports and services. What we can do then is import the Nmap and OpenVas results into Metasploit, and then tell Metasploit to use the imported results from Nmap and OpenVas and go and validate the existence of publicly available exploits against the identified vulnerabilities and open ports and services from Nmap. So now we, with following module, will put these vulnerability scanning and exploitation together. If you look into the results, go down through the list. Your task will be to parse out the results into a human readable context and complete the table with results. In the table with results, what you should have is actually alignment of your port services, vulnerability information, the actual remediation, the actual severity, CVE reference, and so on. And where do you get the CVE? Well, obviously, I don't make it up. The CVE in the case with the R service is located in the references area. Okay, so you can actually use the XML report and manipulate the XML report with Excel to parse out the CVE and CVSS and everything else that I'm asking for, and make some of the manual modification automated. So we're going to just do a quick check to see what's the status of the Kali, and then will conclude the actual demonstration. So if you notice here, we're at a 14%, and what we can do is we can click on the particular scan and then review some results to figure out, what's the status. Did you find anything interesting? So go to, let's see, reports. It's at 14%, and it looks like it only has some 10 log entries. Let's see what those look like. In here, you're gonna notice that there isn't any results that were displayed. So what we can do, they're suggesting that we can reset the filter for displayed information, and here we can or adjust and update the filter settings. So we're saying that the quality must be 70%. We can probably go down to 40%, but the chance for false positive has increased. Then we can tell it, well, maybe it wasn't a full CVE match, it was a partial. That will help it. And then results per page and the severity. We want to include all results, and by default all results are included. It's just these log entries are not necessarily validated against the threshold of 70%. That's why they're not showing up. That's why it's recommended wait until the actual end of the scan where all the accuracy checks have taken place, and that decreases the chance for false positives and false negatives.